Section 1 of Chapter 6 is titled Radical Expressions and Functions. We're going to look at some terminology in this section, just discuss some basics about taking square roots, cube roots, for that matter any root, fifth roots, sixth roots, eighth roots, and you're most used to taking the square root of 4, for example, and getting an answer of 2 because 2 times 2 is 4. That's the reason the square root of 4 is equal to 2. So we'll be introducing in Section 1, we'll be looking a little bit at graphing radical expressions. So let's go ahead and look at quite a few problems. Let's talk about some words as well. First of all, when I ask you to give me the value for the square root of 25, most of us are used to stating that that's equal to plus or minus 5. And that's true because a positive 5 squared gives you 25, and so does a negative 5 squared give you 25. That's the reason there are two answers. These days, however, we often ask for what's called the principal square root, and so what I mean by that is often when asking for the principal square root, you'll only give me the answer of a positive 3 for a problem like this, rather than giving me both of those, the plus or minus 5. On the other hand, if I ask you by putting a sign and the directions say, let's say the directions say, give me the principal square root. In this case, I'm asking you to give me the opposite of the square root of 16. The principal square root of 16 is 4. But I'm asking here for the opposite of that. So in this case, I am asking you to give me a negative 4. So you're going to have to pay attention to directions. If I just say, give me the square root of 25, you're going to give me a positive 5 and a negative 5. If I ask for principal square roots, that's the positive version of the answer. Here, when I ask for the principal square root of 9, I just want 3. But again, the directions would say here, give me the principal square root. However, I'm asking for the opposite of that giving you a negative 4. Just a few problems that I'd like to address now. Again, the directions would say, give me the principal square root. And I put 4 problems up on the board, just wanting to illustrate some situations. First of all, if I have a fraction underneath a radical, like I do here, 25 over 64, you can and need to think of those, the numerator and the denominator, separately, in the event that you could possibly take the square root of those. So would you think of this problem as the square root of 25 over the square root of 64, and individually the square root of 25 is equal to 5, and the square root of 64 is equal to 8, and give me an answer of 5/8. In these 3 problems, again, I just wanted to illustrate the point one more time. If I ask for the principal square root of 144, then I expect that you're going to give me the answer of 12. If I ask for the opposite of the principal square root of 144, I expect that you're going to give me a negative 12. And then finally, if I were to ask you for the square root of a negative 144, I'd expect you to tell me that there's no solution. You could use this symbol to say that. But that's because there is no way to take a number times itself 12 times 12, for example, and get a negative 144. A negative 12 times a negative 12 is a positive 144. So there's no way to do this problem with real numbers. It can be done with imaginary numbers, and that's going to be something that we're going to address in the very last section of this chapter. You should be comfortable with using your calculator and taking square roots, cube roots, fifth roots for that matter, and we'll look at those a little bit further in the chapter. But if you were asked to take the square root of 40 with your calculator, and for example, say I asked you to give me your answer to the thousands place, what you need to do with your graphing calculator is access the yellow second key, and then in the first column above, I believe it's the x squared key, is the square root key. So you would go second square root to do this problem, and what you would have on your calculator screen then is this, and it would open parentheses for you. You would next type in the 40. I would suggest that you get in the habit of closing the parentheses, and the value for that is 6.325. Simple as that. If I were doing this problem with my graphing calculator, I would go second square root. The calculator would open parentheses right here. You would put in the 839.4 divided by the 19.7 and close them there. I'm going to make this a little bit darker again. It opens them for you there. Put this in, divided by the 19.7. Close them, and you should get an answer of 6.528. Again, I might ask you to do just a problem. Show me that you can use your calculator. I have a radical expression up on the board, and I just want to talk about some of the words that we use. The symbol right here, the square root symbol that we often, we call it the square root symbol, is called the radical. There's usually an indice written here, and if it's not written, it means that we want to take the square root. But if I happen to put a 3 here, then that would mean a cube root, or a 4 here would mean a fourth root. What's underneath the radical is called the radicand, in this case the x plus 3. The whole thing is called a radical expression. And what I'd like to do with this particular problem is look at evaluating the radical expression for several values of the variable and then talk about graphing it. This is what I'm going to do. I'm going to insert in the front function notation. So I'm going to say that I have this function, which is a dependent f of x, or x is my independent variable, and I've got the expression on the right hand side with x. And what I'm going to ask of you is I'm going to ask of you to find f of a negative 3. In other words, substitute a negative 3 into this expression. So I do that. And a radical is like telling you to do what's in the parentheses, so do what's underneath first. In this case, negative 3 plus 3 is 0, and the square root of 0 is 0. I might ask you to evaluate the radical expression with a value of 6 in the place of x. So I'm asking you to substitute in for x a 6, then bring that plus 3 along. So I'm asking you to find the square root of 9. Principal square root, give me the value of 3 for an output. And if I asked you to put a negative number in here for x, I would have the square root of a negative 2 plus 3, because I'm substituting in for x a negative 2. And then I'll simplify what's underneath that radical, and then finally I'll take the square root of that. One of the things that we discuss in this chapter is what's the domain of a radical expression, and the domain is the values for x that I can use, the independent variable in this case. This is my independent variable, and there are some numbers for x in this expression that I cannot use because I can't take the square roots of negative numbers. So for example, I'm just going to pick something fairly odd. If I put a negative 10 in here for x, I'd have a negative 10 plus 3, which would give me a negative 7 under the radical. I can't take the square root of a negative 7. At the moment anyway, that's an imaginary number. So what I need to decide here is what values for x would keep this expression positive or equal to 0. So what I do when establishing the domain is I take that radicand, the x plus 3, and I write an inequality that will make that be greater than or equal to 0, and that will establish the domain for me. I'm going to subtract 3 from both sides, and I'm going to find out that the domain of this expression are values that are greater than or equal to negative 3. Those are the kinds of numbers that I can put into this expression. And then next, if I were going to go ahead and evaluate it, now look, notice that I did put values of a negative 3 and a negative 2 and a positive 6. I did put values that were greater than or equal to a negative 3 into this expression. If I had created now, and this is how you would graph this expression, if I had created a table, and so for example, when I put a -3 in to this expression, I got an output of 0. I'm going to go ahead with this -2 next. When I put that in for x, I got an output of 1. And finally, let's stay with this 6. When I put a 6 in for x, I got a value out of 3. What I'd like to do is do a quick sketch of the graph of this expression, and it happens that everything stays above the x-axis. I have my first ordered pair right here where x is a -3 and y is 0. That's right there. And then my next ordered pair is x is a -2 and y is 1. That ordered pair, as I get ready to graph this, is right here. And then when x is 6, y is equal to 3. Now, I actually could have come up with another point in the meantime, but it looks as though this expression is going to go like this, and actually that doesn't come down, that keeps going outward like this. The graph of a radical expression will look very much like this. And what you should do is you should be taking your graphing calculator and you should put into that y equals the square root of x plus 3 into the y1 position. Again, in the graphing feature of your graphing calculator, the graphing feature, remember, is in the top row of your calculator. To the left, in the very, very top row, is a y equals key. If you would hit that y equals key right now, clear any equations that are in those registers for y1, y2, y3, etc. Then go ahead and hit your second square root key. It will open parentheses, type in x plus 3, close parentheses, and then if you could hit the zoom key and select zoom standard. I believe it's the 5th or the 6th item down in that selection. That will open a graphing window for you from a -10 to a +10 on the x-axis and a -10 to a +10 on the y-axis. And you will see this very picture, the graph of this function. If all I were to do was to ask you to describe the domain of this function, what values for x could you put in and get an output that's reasonable, not get a negative number underneath the radical? Again, I just want to remind you, what you care about is that the radicand, the 3x plus 1, has to be greater than or equal to 0, and you just need to solve this inequality, which means subtracting 1 from both sides, and then dividing both sides by 3. No need to flip the inequality symbol. I'm not dividing by a negative number. And you would find out that x has got to be values that are greater than or equal to a -1/3. Now, I'm going to take a quick gander at the possibility of the graph for this. If this is a -1, then I would say that this is where that curve is going to start if I were to graph that function. And you know what? I have a negative sign here, so I am going to be asking for the opposite. But I just wanted you to get a feel for the fact that I need to use values to the right side of, on the x-axis, anything that's greater than or equal to that -1/3. And I'm going to get a radical equation as a graph that's going to arch out to the right. In this case, it's going to be under the y-axis because I have a negative sign in front. I'm not going to graph that one. I'm going to go ahead and graph another one, but I wanted to discuss the domain of that function. Okay, another radical expression that I'd like to find the domain first, then I'd like to create a table of values. I'll pick some values for x and find out what the output will be, or y, the values for the dependent variable, and then we'll graph it. So first of all, I need to make sure that this, under the radical, the radicand, needs to stay greater than or equal to 0. So all you have to do in this problem is to discover that x has got to be greater than or equal to 1. So there's my domain, done with that part. Next, what I would do is if x has got to be greater than or equal to 1, then when I choose to put values in to the expression, I'm going to start with the number 1 when I put it into this particular expression. So 1 minus 1 here is 0, and the square root of 0 is 0. So this expression would have 2 plus Again, I'm going to go ahead and put it all down here. But 2 plus 0, and so my output there would be a value of 2. I'm inclined to try to put numbers in for x that would keep the value positive underneath the radical and would create a natural number when I take the square root of it. The next number that would do that is the number 2, because when I take the square root of 2 minus 1, I have the square root of 1, which is equal to 1. And that's a nice expression I can do without a calculator. So again, this right here is the square root of 1. Square root of 1 is 1, so I have 2 plus 1, where I have an output here of 3. The next number that I would choose to put is a 5 here for x, because I prefer to take 5 minus 1, again substitute in for x of 5, that gives me 4, and the square root of 4 is equal to 2. I like that better, I don't have to mess with the calculator, and then I have 2 plus 2, or 4 as an output. And I probably have enough information to go ahead and graph this now. I'm going to clean this out right here, give myself some room for the graph, and we'll look at, I can see my values are all positive for x, my values for y are all positive. So I'm going to be staying in the first quadrant. My first order pair is when x is 1, y is 2. So again, from here, go over to the right 1 and up 2. My next order pair, x is 2, so I'll go to the right 2 and up 3. There's my next order pair. And then my next one is 1, 2, 3, 4, 5 for x, and 1, 2, 3, 4 for y. And radical expressions all look much the same. They curve on out to the right or to the left. And just notice that this one doesn't go anywhere to the left of that ordered pair, because values for x have to be greater than or equal to 1. This is again evaluating the expression. It's kind of like saying, putting this value of 1 in here is like my saying, find f of 1. And that's putting 1 in for x and finding out the output is 2. And then graph, take a look at a picture of this. So again, as far as radical expressions, be able to tell me the domain, be able to create a table of values, be able to graph it, be able to substitute values in, and also use your graphing calculator again. Again, please hit that y equals key, put this expression in, make sure you have a standard viewing window in, and hit graph. Or hit the zoom key and select zoom standard and it will graph it for you. I'd like to simplify a couple of radical expressions, but the directions would say, and excuse me for a minute, it would say find the following and assume that all the values represent any real number, positive and negative values. This is a particularly challenging section. I want to try to make it not so. Let's take a look at this first problem. I just want to simplify this, or find the square root of 25t squared. Would you please think of it as the square root of 25 times the square root of t squared? Think of those individually, because then you can take a look at the square root of 25 and just say, oh, that's 5. I'm looking for the principal square root. So that right there will give me a positive 5. When I take the square root of t squared, I think of getting an answer of t. And that's because t times t gives me t squared. So the square root of t squared must be t. But what you have to give me in this answer is not just 5t. You have to tell me that it's 5 times the absolute value of t. The reason for this is if you were putting a negative number in for t, when you square that, that would give you a positive answer right here. Well, by writing this as 5 times the absolute value of t, you would always get a positive answer, whether or not t were negative or not. And if t were negative, when you square it, you should get a positive result. So you always have to put a letter. When there's an even exponent, it's an even indice, you have to write that with the absolute value symbol, so that if a negative number were being evaluated, it would become positive when you take the absolute value. Now with a positive number, it doesn't matter at all. A positive number squared is positive as well, and a positive number here for t would give us a positive result. I need to show the absolute value brackets when I'm taking the square root of an expression where there's a variable squared, and in the event that the variable were negative, I need to have that variable, the answer, in absolute value brackets. Let's look at this problem. I can't possibly see how to factor that unless I could have a perfect square, because I'm taking the square root. So what I need to think of doing in this problem is to factor this trinomial. And I happen to notice that that's a perfect square trinomial. And as a matter of fact, it can be factored with a 3t in the front of each of those, because I have the 9t squared here, and probably a 5 in the back of each of these, because their product is 25. Looks as though I'm going to need a minus sign in each one because a minus 5 times a minus 5 is a positive 25. And then the inner and the outer expressions would be a minus 15t each, giving me a minus 30t in total. I might then go ahead and write this as the square root of 3t minus 5. That quantity squared, that's kind of nice because that's just like the square root of t squared, telling me that, you know, again, here it was just the square root of t squared is the variable t. Well, the square root of something squared is just that something. In this case, the 3t minus 5. Because it contains a variable, I have to put it in absolute value brackets. There's only going to be one time when we get ready to culminate and finish this test where I'm going to ask you to simplify or find the values of these expressions. And if I say t or x can represent any real number, then you have to be careful to put the absolute value brackets. The rest of the chapter, sections 2 on out, are basically going to say that the variables are represented by positive numbers only, and we won't bother with the absolute value symbols at all. Really quickly, let's take a look at taking cube roots of numbers. Same situation, kind of interesting though, because now I can take the cube root of negative values, but we're just going to look at positive numbers at first. When I ask you to give me the cube root of 8, I'm asking for a number that when you multiplied it times itself 3 times, you would get 8. That number is just the number 2. Because, again, I just want to write this out so you understand this. Because 2 times 2 times 2 gives me 8, then the cubed root of 8 is equal to 2. So likewise, the cubed root of 64 is equal to 4, because 4 times 4 times 4 gives me 64. Therefore, the cube root of 64 is equal to 4. This one, I'm just asking for the opposite of whatever the cubed root of 64 is. Well, the cubed root of 64 is 4. If I ask for the opposite of that, I just need a negative. The cubed root of a number has only one answer, ever. There is never that situation like with square roots where you would have a positive and a negative version. So, I don't have to worry about that situation with absolute values anymore, and I need to just now look for the number that when I multiply it times itself, I get a negative 8. If I'm taking the cube root of a negative number now, I'm going to get a negative result, in this case a negative 2. And that's because a negative 2 times a negative 2 times a negative 2, again check these out, these two right here equal 4, and 4 times a negative 2 gives me that negative 8. There is just that possibility. Likewise, the fifth root of a negative 32, is also a negative 2, because a negative 2 times a negative 2 times a negative 2 times a negative 2 times a negative 2 is equal to a negative 32. When you see a problem like this, it's got variables in it, just separate it. Now I'm this section, I've got several examples, all of them unusual roots, 4th roots, 6th roots, 10th roots, 201st roots. Watch the pattern. When I take the 4th root of 16, principal root, 4th root, I'm looking for the number 2, because 2 times 2 times 2 times 2 is equal to 16. If I ask for the 4th root of 16, but I have a negative sign in front, I want the opposite of the 2, so a negative 2. Be careful, when I take even roots of a variable raised to a power, even though I know the answer to this is y, because it's a 10th root, and I know that y times y times y, etc., times itself 10 times will give me y to the 10th. Y will be my solution, but because that's an even root and negative numbers could be a dilemma, I have to put an absolute value symbol around that. When I take the 201st root of 2x plus 4 to the 201st power, that's an odd root. My answer is just 2x plus 4. No absolute value brackets are necessary. Please notice that these match, so I just get the value that's the base. Again, over here, I've got the 6th root of 2a to the 6th power. That means I'm looking for 2a. However, the a has got to be in absolute value brackets because I have an even root here. Unless I got a negative number that I put in for here for a, I have to be sure to take the absolute value of that and get a positive result. I'm taking the 5th root here of a negative 1 over 32. Think of that as the 5th root of a negative 1 over the 5th root of 32. And the 5th root of a negative 1 is just a negative 1, because it times itself 5 times will give you a negative 1. And the 5th root of 32 is 2, because it times itself 5 times gives you 32.